Now we discuss diffraction and polarization in this class. Here already I told that electromagnetic wave, light is a electromagnetic wave, already explained. Now we discuss in this diffraction and polarization. Now first of all, diffraction. Diffraction means what? Here simple thing, when bell rings we are listening sound. Bell manaku avagane manaku evostund sound vastundi ante enti akkada sound waves are diffracted. Sound waves are diffracted. What is diffraction of sound? Bending of sound waves at the edges of obstacles, windows, doors, like that. That is called diffraction. Bending of sound waves at the edges of obstacles. When bell rings, sound waves are, we are listening sound waves. Now that sound waves enters into our room all the time. So we are listening sound, how sound waves are propagates in the form of waves. That waves are bends at the interface, bends at the edges of obstacles, windows, like that. Now here in the same way we have diffraction of light. We have a diffraction of light. Here now diffraction of light means what here? Same thing, phenomena of bending of light around the corners and the encroachment of light within the geometrical shadow of the opaque obstacles. Here now this is the slit. Now this is the slit. Now on the time, because of slit, what happened here? Light enters here. Now this is the slit. So on the time it bends. Here what is diffraction? Same thing, simple definition, bending of light, phenomena of bending of light at the edges of obstacles. That is called what? Diffraction. Otherwise we say like this, phenomena of bending of light around the corners and the encroachment of light within the geometrical shadow of the opaque obstacles. Opaque obstacles. Here actually this is the slit. So what happened? We are getting now x and y. Here x and y are the regions of diffraction. X and y are regions of diffraction. Here we have obstacle. We have obstacle. So on that time here also we are getting x and y. X and y are region of what? Diffraction. Anyhow, bending of light at the edges of obstacles. Bending of light at the edges of obstacles is called what? Diffraction of light. We have little difference between interference and diffraction. Now next one, here we discuss now here relation between interference and diffraction. Now we have Fresnel distance. Here Fresnel distance is the distance from the slit at which the spreading of light due to diffraction becomes equal to size of the slit. Here same like interference, here also we have slits and screen. Now Fresnel distance is the distance from the slit at which spreading of light due to diffraction becomes equal to size of the slit. Here spreading of light here, spreading of light due to diffraction becomes equal to what? Size of the slit. So that particular distance is called what? Fresnel distance. What is formula? Y1 is equal to what? Lambda d by d. At Fresnel distance y1 is equal to what? D. Here already you know that fringe width same like that only. At Fresnel distance y1 is equal to what? D. Now what we are getting? Y1 is equal to, we substitute now small d. Now d becomes what? Df. D becomes what? Df. Now df is equal to what we write now? D square by lambda. Df is equal to what we write? D square by lambda. If the distance between the, what is capital D? Here slit and screen is less than Fresnel distance, then the diffraction effects may be regarded as absent. When we are getting diffraction effects, here when diffraction effects are absent, if the distance between the slits and screen is less than Fresnel distance, now on that time diffraction effects may be regarded as absent. Now ray optics may be regarded as what? Limiting case of wave optics. Here ray optics may be regarded as limiting case of wave optics. Here in case of ray optics, now this is possible. What is the distance between the slits and screen is less than what? Fresnel distance. Now we discuss difference between interference and diffraction. Now interference, what I told? Interference means what? Interference is due to what? Superposition of two different wave trains coming from coherent sources. Two coherent sources నుంచి టూ వేవ్స్ వచ్చినప్పుడు అవి ఏమవుతాయి? సూపర్ ఇంపోజ్ అవ్వడం వల్ల మనకి ఏమొస్తుంది? ఇంటెన్సిటీ మారిపోతుంది, వేరియేషన్ ఇన్ ద ఇంటెన్సిటీ. variation in the intensity in the region of superposition of light waves. Light waves coming from what? Coherent sources. Now, what is diffraction? Diffraction is due to the superposition of secondary wavelets from the different parts of the same wavefront. Now, in case of interference, we have two sources. From these two sources, we are getting two waves. Now, these waves are superimposed. We are getting bright and dark bands on the screen. That is interference. Now, diffraction is due to what? Superposition of secondary wavelets from the different parts of the same wavefront. Now, this is the source. It produces wavefront. Now, every point on the wavefront acts as a source of secondary wavelets. Now, waves coming from the here sources on the wavefront. Here this, according to Eigen's principle, every point on the primary wavefront acts as a source of secondary wavelets. Now, these secondary wavelets are superimposed on the time we are getting diffraction. Is it clear? Here when diffraction interference takes place, here superposition of light waves coming from the two coherent sources. Here superposition of light waves coming from the same wavefront. That only given first one. Here diffraction is due to what? Superposition of secondary wavelets from the different parts of the same wavefront, and fringe width is generally constant. Fringe width means what? Distance between successive bright or dark fringes, and fringe widths are of varying width. Here in diffraction, same. Here variation in the intensity only. In interference, we are getting variation in the intensity. Diffraction also we are getting variation in the intensity. But here fringe width is generally constant. But here fringes are of varying width. Here width decreases. Now, all the maximas have the same intensity. The maximas are of varying intensities. Here maximas also having varying intensity. And there is a good contrast between what? Maxima and minima. There is a poor contrast between maxima and minima. It is very difficult to understand this diffraction. Now, here contrast is more. There is a good contrast between maxima and minima. We have lot of difference between maxima and minima. Here we have poor contrast between what? Maxima and minima, like that. Here understand now, interference means what? Superposition of light waves coming from the two coherent sources. That is superposition of light waves coming from two coherent sources. What we are getting here? Alternate bright and dark bands formed on the screen. So anyhow, we are getting variation in the intensity. Variation in the intensity in the region of superposition of light waves is called what? Interference. But here diffraction also same thing. But here superposition of light waves coming from the what? Same wavefront. Here superposition of secondary wavelets from the different parts of the same wavefront. Here according to Eigen's principle, already you know that every point on the primary wavefront acts as what? Source of secondary wavelets. Now, these secondary wavelets superimposed, on that time we are getting a variation in the intensity. That only diffraction. Now, difference is what I told. Fringe width is same, here fringe width is different. Here maximas, all maximas having what? Same intensity, but here different. And one more thing what I told. Here good contrast between what? Maxima and minima. Here poor contrast between what? Maxima and minima. Like that. Next one, we have polarization. Here in entrance examination, we have more problems on interference and diffraction. Now, first of all, now we discuss polarization. Here, polarization. Suppose here, what is polarization? Here, what I told now, already explained, last class already explained. Here, light waves are electromagnetic waves. Light waves are electromagnetic waves. Now, next one, here, light waves are electromagnetic waves. In this, electric field vector, variations in the electric field vector are more. That is why electric field vector is called what? Light vector. Electric field vector is called what? Light vector. Now, here, so in case of electric field vector, next one, here, look here. Now, polarization of light waves. What is polarization? What is unpolarized? What is polarization? What is unpolarization? What is unpolarized light? Natural light is unpolarized light. Natural light is unpolarized light. What is polarization? Here, in general, light rays are electromagnetic waves. Light rays are electromagnetic waves. Now, in this, here, in electromagnetic wave, electric field vector vibrates, magnetic field vector vibrates, but here significance of electric variations in the electric field vectors are more. That is why electric field vector is called what? A light vector. Now, in electric field, in electromagnetic wave, in ordinary light, electric field vector vibrating in all directions like this. Now, this unpolarized light is represented by dots with double-headed arrows. Dots with double-headed arrows. It is unpolarized light. Natural light is unpolarized light. Natural light is unpolarized light. Here, unpolarized light is represented by here dots with double-headed arrows or stars like this. It is unpolarized light. Unpolarized light means what? Electric field vector vibrating in all directions. Polarization. What is polarization? Polarization would mean restricting the vibrations of light waves to one plane, either perpendicular to the plane of incidence or parallel to the plane. Parallel to the plane like that. Here, now, a simple example. First, you understand the polarization, unpolarization. Now, in summer, we are using spectacles, sunglasses. If you are using sunglasses, we feel cool. తెలుసు కదా, మనం ఎండాకాలంలో సమ్మర్లో ఏం చేస్తాం, సన్ గ్లాస్ యూజ్ చేస్తాం. ఆ సన్ గ్లాసెస్ అనేవి ఏంటి? పోలరైడ్స్. ఆ పోలరైడ్స్ ఏం చేస్తాయి? ఇంటెన్సిటీని తగ్గిస్తాయి. అయితే ఇక్కడ ఈ అన్పోలరైజ్డ్ లైట్లో ఎలక్ట్రిక్ ఫీల్డ్ వెక్టార్ ఇట్ ఈస్ వైబ్రేటింగ్ ఇన్ ఆల్ డైరెక్షన్స్, perpendicular to the plane of incidence and parallel to the plane of incidence. How we represent unpolarized light, natural light? It is represented by dots with double-headed arrows. Dots with double-headed arrows. దాన్ని మనం పోలరైజేషన్ చేస్తాం. పోలరైజేషన్ అంటే ఏంటి? ఇక్కడ we have polarides, we have crystals. Now, if unpolarized light incident on the crystal, here tourmaline crystal, it becomes what? Polarized. Here we have perpendicular components and parallel components. Here, now, that only given here. What is given? In natural light, millions of transverse vibrations occur in all the directions perpendicular to the direction of propagation of the wave. Here, already I told that transverse waves are, here light waves are transverse waves. Now, in natural light, how many transverse vibrations are there? Millions of transverse vibrations. Millions of transverse vibrations occurs in all the directions perpendicular to direction of propagation of wave. But for convenience, we can assume that rectangular components of vibrations with one component lying on the plane of the diagram, other perpendicular to the plane of the diagram. Here we have million number of transverse vibrations, but we are considering only perpendicular components, rectangular components. Now, some electric field vector vibrating perpendicular to plane of incidence, some are electric field vector vibrating parallel to the plane of incidence like that. Now, here, so anyhow, here what we take now, unpolarized light, it is the combination of two types of electric field vibrations. Some are vibrating perpendicular to the plane of incidence, some are vibrating parallel to the plane of incidence. Now, we restrict, here we are restricting the vibrations of light waves. Polarization would mean what? Restricting the vibrations of light waves to one plane, either perpendicular to the plane of incidence or parallel to the plane of incidence. దట్ ఓన్లీ. అంటే ఇక్కడ మనకి ఈ న్యాచురల్ లైట్లో మనకు ఎలక్ట్రిక్ ఫీల్డ్ వెక్టార్ వైబ్రేటింగ్ ఇన్ ఆల్ డైరెక్షన్స్. నౌ వీఆర్ కన్సిడరింగ్ టూ కాంపనెంట్స్. సమ్ ఎలక్ట్రిక్ ఫీల్డ్ వెక్టార్ వైబ్రేటింగ్ పర్పెండిక్యులర్ టు ద ప్లేన్ ఆఫ్ ఇన్సిడెన్స్, some electric field vector vibrating parallel to the plane of incidence. Now we restricting. Polarization means what? Restricting the vibrations of light waves to one plane, either perpendicular to the plane of incidence or parallel to the plane of incidence. Now what we understand here, unpolarized light is the combination of dots and double-headed components. The dot component means what? Perpendicular to the plane of incidence. Parallel components means what? Here arrow indicates what? Parallel to the plane. Now we restrict. Now next one here like this. Now light waves are electromagnetic waves with electric and magnetic fields oscillating at right angles to each other. Now here electric and magnetic fields are oscillating how? Right angles to each other and also to the what? Direction of propagation of the wave. Therefore light waves can be polarized. Light waves can be polarized. First we take unpolarized light. Unpolarized light incident on the polarizer. Polarizer means what? Tourmaline crystal. What happened? This tourmaline crystal absorbs one component. Here dot components it is absorbed. That's why we are getting only parallel components. We are getting parallel components. Now unpolarized light incident on the crystal, that is called what? Polarizer. Now these are arrow components, these are parallel components. Now these are called what? Polarized light. Now what happened? if tourmaline crystal, if unpolarized light incident on the tourmaline crystal, it absorbs one component, dot components it absorbs, we are getting only parallel components. Now it is polarized light. If polarized light incident on the another crystal, that is called what? Analyzer. If unpolarized light incident on the crystal, that is called what? Polarizer. If polarized light incident on the same tourmaline crystal, then it is called what? Analyzer. It is called what? Analyzer. Now like this. Again we are getting plain polarized light. Here same thing. Here if we take unpolarized light, here suppose if the transmission axis is perpendicular, here these two axes, this is optic axis. Now if the optic axis is perpendicular, on that time we are not getting light. Here actually it is 90 degrees. If it is rotated 90 degrees, if both are in same direction, we are getting plain polarized light. Actually if it is optic axis is perpendicular to this, on that time we are getting no light, like that. Here anyhow what we understand, if unpolarized light incident on the tourmaline crystal, it absorbs one component. It absorbs one component, it produces only one component. So anyhow, what is polarization? Polarization would mean restricting the vibrations of light waves toward one plane, either perpendicular to the plane of incidence or parallel to the plane of incidence, like that. Next one, here, look here, same thing. Here unpolarized light incident on the polarizer, vibrations are parallel to the crystallographic axis are transmitted, those perpendicular to the axis are absorbed. Here same thing, here we have unpolarized light means what? Dot and arrow components. Here dot components are absorbed, dot components are absorbed. Now here transmitted light is plane polarized, transmitted light is plane polarized. Now the plane which contains crystallographic axis, vibrations transmitted from the polarizer is called what? Plane of vibration. Here this is called what? Plane of vibration. Plane of vibration means what? Plane which contains crystallographic axis, vibrations transmitted from the polarizer. This is polarizer. Unpolarized light incident on the crystal, so it is called what? Polarizer. Now this plane is called what? Here plane of vibration. Otherwise plane which is perpendicular to plane of vibration, that is called what? Plane of polarization. Now this is perpendicular to this, so it is called what? Plane of polarization. This is called what? Plane of vibrations, plane of polarization, like that. Here what happened here? Here dot components are absorbed. If unpolarized light incident on a crystal, it is absorbed dot components, it produces only parallel components. That's why in summer we are using polarized glasses, so that polarized glasses absorbs one component. So where we feel cool, intensity becomes off. Suppose some 5 intensity is there. Suppose 5 units of intensity is there. If we are using sunglasses, polarized glasses, intensity becomes what? Off. That's why here in summer we are using cooling glasses. That cooling glasses decreases the intensity of light rays, like that. Next one, here we have polarization by reflection and Brewster's law. Here now suppose it is glass plate, whatever it may be, this is one material. Now we take unpolarized light incident on the glass plate. On that time a part of light is reflected, some part of light is refracted. Now that reflected light is polarized. Here dot components are reflected, here dot components are reflected, and arrow components, some unpolarized light is transmitted. Here the incident light wave is made of what? Parallel vibrations. Here pi components on the plane of incidence and perpendicular vibrations. Here what happened? Here look here, angle of this is incident light ray, incident unpolarized light, incident unpolarized light, incident at some angle. Now reflected light ray is polarized, it is a reflected light ray is polarized. Now at a particular angle of incidence, reflected light ray is completely polarized. That particular angle is called what? Here polarizing angle. At polarizing angle, here at a particular angle theta, the parallel components completely refracted, and whereas the perpendicular components partially get refracted and partially get reflected. Here reflected components all lie in perpendicular to plane of vibration and hence plane polarized. Here these reflected components, here now it is unpolarized light. Unpolarized light means what? It is the combination of dot components and arrow components. Unpolarized light, it is natural light. Natural light is incident on the glass plate, any material. On that time what happened? Reflected light is polarized. But at a particular angle of incidence, reflected light ray is completely polarized. So that particular angle of incidence is called what? Polarizing angle. That particular angle of incidence is called what? Polarizing angle. So on that time reflected and refracted rays are perpendicular to each other. Now this is reflected, now this is refracted. Now at a particular angle of incidence, reflected light ray is completely polarized. So on that time reflected and refracted rays are perpendicular. So theta p plus r is equal to what? 90 degrees, and r is equal to what we write? Now here r is the angle of refraction according to laws of reflection. So it is also what? Theta p. Now from diagram, r plus theta p is equal to what? 90 degrees. Now total angle how much? 180 degrees. 180 minus 90, 90. Now theta p plus r is equal to 90. R is equal to what? 90 minus theta p. Refractive index of a medium. Now mu is equal to what? Sin I by sin r. Sin theta p by sin r. R is equal to what? 90 minus theta p. So mu denser medium with respect to air medium is equal to what? Tan theta p. So this is called what? Brewster's angle. What is Brewster's law? Here refractive index of a medium is equal to what? Tangent of angle of polarization. What is angle of polarization? At a particular angle of incidence, reflected light ray is completely polarized. At a particular angle of incidence, reflected light ray is completely polarized. At that particular angle, reflected and refracted rays are perpendicular. Reflected and refracted rays are perpendicular. So refractive index of a medium is equal to what? Tangent of polarizing angle. Tangent of polarizing angle. You must remember at polarizing angle, reflected and refracted rays are perpendicular 90 degrees. So theta p plus 90 plus r is equal to what? 180 degrees. How this is theta p? According to laws of reflection, angle of incidence is equal to what? Angle of reflection. Now angle of reflection also theta p. Now from this theta p plus r is equal to 90 degrees. So refractive index Snell's law, mu is equal to sin I by sin r. So mu d is equal to what? Tan theta p. So this is called what? Brewster's law. Like that. Next one here. Now uses of polarites. What are polarites? Here these crystals only. Here H polarites is prepared by here taking a sheet of polyvinyl alcohol, long chain polymer molecules subjected to what? Large strain. Here molecules are oriented parallel to the strain and material becomes what? Double refracting. When strained with iodine, the material behaves what? Here dichloric crystal. Dichloric crystal, where we are using these polarites in polarite sunglasses, polarite filters. Now crystals only, polarites. Now here sunglasses, polarite sunglasses, and also we have in other applications for laboratory purpose in a headlight of automobiles, in 3-dimensional motion pictures, in window panes, and in windshields in automobiles. Okay. Here what you understand? What is polarization? Polarization means what? Here unpolarized light. Here natural light is the unpolarized light. Natural light is the unpolarized light. Unpolarized light means what? Electric field vector vibrating. Here perpendicular to the plane of incidence and parallel to the plane of incidence. Intensity is more. Now what is polarization? Here natural light is unpolarized light. What is polarization? Polarization would mean restricting the vibrations of light waves to one plane. Here we are restricting the vibrations of light waves to one plane. Now either perpendicular to plane of incidence or parallel to the plane of incidence. Now if you are using polarite sunglasses, we feel here intensity is very less. Intensity is very less. Okay. The displacements of two interfering light waves are y1 is equal to 4 sin omega t. y1 is equal to how much? 4 sin omega t, and y2 is equal to 3 cos omega t. 3 cos omega t. Here we have question. Amplitude of resultant wave is y1, y2 are in centimeters, CJ system. Here we have question. Here the amplitude of resultant wave, or find the amplitude of resultant wave. Find the amplitude of resultant wave, we have a question like this. Here what is given? Displacements of two interfering light waves are y1 is equal to how much? 4 sin omega t. y1 is equal to 4 sin omega t, and y2 is equal to what we write? What we have? 3 cos omega t. Now cos is equal to what we write? Sin 90 plus theta, how much? Cos theta. Sin 90 plus theta is cos theta. So this is y2. y2 is equal to what we write now? 3 sin omega t plus pi by 2. Sin 90 plus theta, how much? Here sin 90 plus theta is cos theta. Here, so that's why. Now what is phase here? Amplitude how much here? General equation, what is formula? A sin omega t. Y is equal to A sin omega t. From this, here A1 how much? A1 is 4, A2 is 3. Here pi 1 how much? Omega t. Pi 2 how much? Omega t plus pi by 2. Omega t plus pi by 2. From this, here we calculate phase difference. Now phase difference how much? Delta pi. Here phase difference delta pi is equal to pi 2 minus pi 1. How much now? Omega t plus pi by 2 minus omega t. Plus omega t minus omega t gets cancelled. We are getting pi by 2. Now what is formula for resultant amplitude? Under root of a1 square plus a2 square plus 2a1 a2 cos theta cos pi. Now resultant amplitude. Here we want to calculate resultant amplitude, A resultant. What is formula? A resultant is equal to, we have formula, A resultant is equal to under root of a1 square plus a2 square plus 2a1 a2 cos pi, 2a1 a2 cos pi, like this. We substitute now. Here a1 square, a1 how much? 4 square, 4 square plus 3 square plus 2 into 4 into 3 into cos pi by 2, cos pi by 2. How much now? 16 plus 9, cos pi by 2 how much? 0, 0 into something 0. 16 plus 9 how much? Root 25, root 25 how much? 5 centimeters. Is it clear? Now we have two waves. Here displacements of interfering of two light waves are given, y1, y2. Now amplitude of resultant wave, what is formula? Under root of a1 square plus a2 square plus 2a1 a2 cos pi. Now pi how much? Phase difference pi by 2. How we calculate phase difference? It is sine function. So cos function also we write in terms of sine. How we write? Sin 90 plus theta is cos theta. So sin omega t plus pi by 2. So what is phase difference here? Pi by 2. So what is resultant amplitude now? 5 centimeters. Now down here we have two coherent sources of different intensities, send waves. Here two coherent sources of different intensities send waves that interfere. Send waves that interfere. Here, and also the ratio of maximum and minimum intensity, maximum to minimum intensity, ratio of maximum to minimum intensity is 25. Here, the intensity ratio of two sources. They are asking question. The intensity ratio of intensity ratio of the sources is, we have question like this. Here, first you understand question, you read question now. What is given? Two coherent sources of different intensities. Two coherent sources of different intensities send waves that interfere. Ratio of maximum to minimum intensity is 25. Ratio of maximum to minimum is 25. The intensity ratio of two sources. Now suppose here waves, two waves having intensity, what we take? I1 and I2. Here, what is given here actually? In ratio of maximum to minimum intensity, I maximum by I minimum given. I maximum by I minimum how much? 25. Now, intensity ratio of two sources. Let I1, I2 be the intensities of two sources. They are asking question I1 by I2. Here, intensity ratio of sources. How we calculate now? I maximum, already explained last class. I maximum means what? I maximum, what is formula? Root I1 plus root I2 whole square. I minimum, root I1 minus root I2 whole square. This is maximum intensity is equal to what? 25. Now, squaring on both sides, we take square root on both sides. 25 means what? What we write? 5 square. So, take square root on both sides. Take square root on both sides. What we are getting now? Root I1 plus root I2. Root I1 plus root I2 by root I1 minus root I2 is equal to what? 5. We take square root on both sides. From this, here, we do cross multiplication. Here, root I1 plus root I2 is equal to 5 into root I1 minus root I2. From this, here, root I1 plus root I2 is equal to what? 5 root I1 minus 5 root I2. From this, here minus 5 root I2 bring this side. Here root I1 send that side, we are getting root I2 plus 5 root I2 is equal to 5. Here this is 5 root I1, root I1. So 5 root I1 minus root I1. From this 5 plus 1, 6 root I2. 6 root I2 is equal to 4 root I1. From this, here what we are getting now? Here I2, this is I1. From this, root I1 by root I2. Root I1 by root I2 is equal to what? 6 by 4. Now 2 2's, 2 3's, 3 by 2. Yes, squaring on both sides. What we are getting now? Root I1 by I2 whole square. So I1 by I2 is equal to 3 by 2 whole square. 3 by 2 whole square how much? 9 by 4. So what is the answer now? 9 by 4. 9 is to 4. Is it clear? What is given question? Ratio of maximum to minimum intensity given. We have two waves, two coherent sources of different intensities and waves that interfere. Now ratio of maximum to minimum intensity is 25. They are asking intensity ratio of sources. So I maximum by I minimum is 25. We want to calculate ratio of intensities I1 by I2. I1 by I2 is equal to how much? How? Now you know formula for maximum intensity. Maximum intensity, what is formula? Root I1 plus root I2 whole square. Minimum intensity how much? Root I1 minus root I2 whole square is equal to what? 25. 25 what we write? 5 square. We take square root on both sides. So that squares will get cancelled. We simplify. What we are getting answer now? I1 by I2 how much? 9 by 4. Note down. Two sources of intensity 2i and 8i. 2i and 8i are used in an interference experiment. Intensity at a point where the waves from two sources superimpose with a phase difference 0, pi by 2 and pi. How we calculate now? We take like this. Let I1 is equal to 8i. Here we have I1 is equal to, what we take now? I1 I1 is 2i, I2 how much? 8i. I1 is 2i, I2 how much? 8i. Here we want to calculate intensity, resultant intensity. We want to calculate resultant intensity in 3 cases. First case, what is that? Phase difference how much? 0. Second case, phase difference how much? Pi by 2. Third case, phase difference how much? Pi. What is formula for resultant intensity? Here already I told that I is equal to how much? I1 plus I2, 2 root I1 I2 cos pi. 2 root I1 I2 cos pi. Here first one, A bit pi is equal to what? 0. Becomes what? It becomes what? I is equal to what? I1 plus I2, 2i plus 8i plus 2 into root of 2i into 8i into cos 0. Cos 0 how much? 1. Cos 0 is 1. So I is equal to how much? 2i plus 8i, 10i. 10i plus 2 into root of 16i square. Cos 0 how much? 1. So 10i plus 2 into 4i. Cos 0 is 1. Cos 0 how much? 1. So into 4i. What we are getting now? Here 10i plus 8i. 10i plus 8i how much? 18i. So what is the answer now? First answer 18i. 18i only correct. Is it clear now? What is formula for resultant intensity? I1 plus I2, 2 root I1 I2 cos pi. For second one, pi by 2. Cos pi by 2 how much? 0. Now for second case, I is equal to what? I1 plus I2, 2i plus 8i. Here 2 root 2i into 8i into 0. Cos pi by 2 0. So what we are getting now? 2i plus 8i. Cos pi by 2 is 0. 0 into something 0. So I is equal to what? 10i. I is equal to 10i. Like that. Next one, C bit. What is that? Resultant intensity. Third case, cos 180 how much? Minus 1. Same thing. Here cos 180 is minus 1. So what we write now? 2i plus 8i minus 2 into root of 16i square. Here cos pi by 2 how much? Cos 180 is minus 1. Same thing. 2i plus 8i plus 2 into 16i square. Cos pi by 2 how much? Cos pi is minus 1. Cos pi is minus 1. So I is equal to 10i plus 2 into how much here? 4i minus 4i. Now 10i minus 8i. 10i minus 8i how much? 2i. So they are giving options. First option how much? 18i. First option is 18i. Second option is second. First bit answer what is that? 18i. Second bit 10i. Third bit what is that? 2i. 3 answers. Is it clear? You remember this formula. Intensity is equal to what? I1 plus I2, 2 root I1 I2 cos pi. Intensity is equal to I1 plus I2, 2 root I1 I2 cos pi. Like that. Note down. The path difference between two interfering waves. The path difference between two interfering waves. Two interfering waves. Interfering waves at a point on the screen. At a point on the screen. At a point on the screen is lambda by 6. Lambda by 6 from the central maximum. From central maximum. From central maximum. Ratio of intensity at this point and that at the central fringe will be. Here they are asking question. The ratio of intensity. Ratio of intensity at this point. Ratio of intensity at this point. At this point and that at the central fringe. And that at the central fringe will be. at the central fringe will be like that. Here, first you understand question, you read question now. Here, what is given? Path difference between two interfering waves at a point on the screen. Path difference between two interfering waves are given. How much? Lambda by 6 from central maximum. And path difference delta x is equal to lambda by 6. Now, what is question now? Ratio of intensity at this point and that at the central fringe. Now, we have screen like this. It is central maximum. Suppose P be a point like this. Here path difference we know. This is central fringe. At the central fringe, what is intensity? Maximum intensity. Maximum intensity how much? 4I0. Now, we want to calculate ratio of intensity at this point and that at the central fringe. So, we want to calculate intensity at point by intensity at 0. Here, what is formula for intensity? In general, what is formula for intensity? Intensity is equal to how much? 4I0 cos square pi by 2. At central fringe means what? At point O, pi is equal to what? 0. Now, IO is equal to how much? 4I0 into cos 0, cos square 0. So, at central fringe how much intensity? 4I0. Remember, so intensity at central fringe, it is maximum intensity how much? 4I0. Now, at point where? At O, at central fringe. At point P, phase difference we know, path difference we calculate. What is pi here? Path difference. So, we calculate path difference at point P. Here path difference is equal to what? 2 pi by lambda into delta x. 2 pi by lambda into delta x. Pi P is equal to what? 2 pi by lambda into delta x how much? Lambda by 6. Lambda gets cancelled. Now, what we are getting now? Here 2 1s, 2 3s, we are getting pi by 3. We are getting pi by 3. Now, same thing, intensity at point P. Intensity at point P is equal to what? 4I0 cos square pi P by 2. Intensity at point P, what is formula? 4I0 cos square pi P by 2. Now, from this, intensity at point P is equal to 4I0 into cos square pi P value how much here? Pi by 3. So, pi by 3 into 2. How much now? Here from this, intensity at point P is equal to 4I0 cos square pi by 6. Cos pi by 6 value how much? Cos 30 degrees. Cos 30 how much? Cos 30 is root 3 by 2. So, cos square 30 how much? Cos square 30 how much? Cos 30 is root 3 by 2. Root 3 by 2 whole square. 3 by 4. 4 gets cancelled. Now, 3I0. Now, intensity at point P by intensity at central maximum. How much? 3I0 by 4I0. What is the answer now? 3 by 4. Like this. So, ratio of intensity at point P to intensity at central maximum was 3 by 4. 3 by 4 means what we write? 0.75. We have option 0.75. 3 by 4 how much? 0.75. Like that. Is it clear? Here, otherwise directly we take intensity is directly proportional to what we take? Cos square pi by 2. Cos square pi by 2. You remember, central maximum, intensity at central maximum always 4I0. Intensity at central maximum how much? 4I0. Now, we want to calculate phase at point P. Phase at point P, what we have? Relation between phase difference and path difference. Phase difference is equal to 2 pi by lambda into path difference. That is why we calculate intensity, phase difference at point P. After that, we calculate intensity at point P like that. So, what is the answer now? 0.75 like that. Note down. Here we have more problems on interference and few problems on, very few problems on diffraction. So, first we discuss more problems in interference only. Next one, here, next question. In Young's double slit experiment, in Young's Young's double slit experiment, 12 fringes are observed, 12 fringes are observed to be formed, or observed to be formed, observed to be formed in a certain region of, in a certain region, certain region of the screen, region of the screen, when light of wavelength 600 nanometers used, when light of wavelength 600 nanometers used, 600 nanometers is used, if the light of wavelength, if the light of wavelength 400 nanometers is used, here the number of fringes observed in the same region of the screen, the number of fringes observed in the same region of the screen, observed in the same region of the screen, will be. Now first you understand question. What we have question now? In Young's double slit experiment, 12 fringes are observed to be formed in a certain region of screen when a light of wavelength 600 nanometers is used. Now on the time, here fringe width, here first of all what is given, lambda 1 is equal to what, 600 nanometers, n1 how much, 12 fringes, some certain region of space. After that, if the light of wavelength 400 nanometers is used, number of fringes observed in the same region of the screen, now lambda 2 how much, 400 nanometers, 400 nanometers, we want to calculate n2. Here lambda is more, here fringe width, beta is equal to what, lambda d by d. Now fringe width depends on what, here lambda value, that's why now same region, that's why n lambda is equal to constant, So what we write now, n1 lambda 1 is equal to what, n2 lambda 2. Here what is lambda, wavelength of the wave. Now in certain region, here number of fringes into wavelength. In certain region what we take, number of fringes into wavelength. So that's why region is same region of screen, So that's why n lambda is equal to constant. So n1 lambda 1 is equal to what, n2 lambda 2. In ray optics also, here number of waves in certain thickness of slab. In ray optics also we are using same formula. Here n1 lambda 1 is equal to what we are taking, n2 lambda 2. Now n1 how much? n1 is 12, lambda 1 how much, 600. n2 we want to calculate, lambda 2 how much, 400. Now 200 2s, 200 3s, how much now, 2 1s, 2 6s are. Now n2 is equal to what, 6 3s how much, 18. So what is the answer now? 18 fringes. Is it clear? In certain region, here n lambda is equal to constant. What is n? N represents what, number of fringes, lambda represents what, wavelength. So region is constant. So what we write now, n1 lambda 1 is equal to what, n2 lambda 2. That's why what is the answer now? n2 is equal to what, 18, like that. Fringe width at a distance of 50 centimeter, from the slits, in YDSC, Young's double slit experiment, for light of wavelength, light of wavelength. For light of wavelength, 600 angstroms. 600 angstroms is 600 angstroms is 0.048 centimeters. The fringe width at the same distance. We have question. The fringe width at the same distance. Fringe width at the same distance for lambda is equal to 5000 angstroms will be like this. Now we have question. Fringe width at a distance of 50 centimeters from the slits in Young's double slit experiment for a light of wavelength 600 angstrom, 6000 angstroms is 0.048. Now lambda 1, wavelength of how much? Lambda 1 is 6000 angstroms. Fringe width how much? 0.048 centimeters. From this, next what is question now? The fringe width at the same distance for, here distance of screen how much given? 50 centimeters given. Now distance of the screen is 50. Now D1 is 50, D2 also 50. The fringe width at the same distance for lambda is equal to what? 5000 angstroms will be. Lambda 2 is equal to 5000 angstroms. We want to calculate beta 2. First time fringe width what we take? Beta 1. Second time fringe width what we take? Beta 2. Now what is variable here? Wavelength variable. ఇక్కడ తరంగ దైర్ఘ్యం మారుతుంది, అప్పుడు ఫ్రింజ్ విడ్త్ ఏమైతే మారుతుంది మనకి. బీటా ఈజ్ ఈక్వల్ వాట్ వే ఫార్ములా? లాంబ్డా డి బై డి. Beta is equal to what by formula? Lambda d by d. Now here d, capital D is constant, small d also constant. They didn't talk about distance between the slits, so we take constant. So from this, you know this formula, this derivation also explained. Now last class explained, beta proportional to what we have? Lambda. So from this, when here d is constant, capital D is constant, small d is constant, beta proportional to lambda. So beta 2 by beta 1, beta 2 by beta 1 is equal to what? Lambda 2 by lambda 1. From this, lambda 2 how much? 5000. 5000 by lambda 1 how much? 6000. So 1005, 1006. We are getting 5 by 6. From this, beta 2 is equal to 5 by 6 into beta 1. So 5 by 6 into beta 1 how much? 0.048. So how much we are getting? 6 ones, 0, 0, 6 eights, how much? 48. How much now? 5 eights, 40. Here from this, beta 2 is equal to 5 eights, how much? 40. Where we keep point after 3 decimals. So 0.04, 0.04 centimeters. So what is the answer now? 0.04 centimeters. Note down. Is it clear? What is given? Why we are taking D2 also 10, 50? Given the fringe width at the same distance. Fringe width at the same distance. So that's why distance of the screen from the slits is same. So D1 is equal to D2 is equal to what? Capital 50 only. So D is constant. So beta proportional what we write? Lambda. Beta 2 by beta 1 how much? Lambda 2 by lambda 1, like that. A double slit apparatus. Here a double slit apparatus. A double slit apparatus is immersed in a liquid of refractive index, in a liquid of refractive index 1.33. 1.33. It has slit separation of 1 millimeter. It has slit separation of 1 millimeter. It has slit separation of 1 millimeter, and distance between the planes of the slits and screen is 1.33, and distance between the distance plane of slits and screen 1.3. Slits and screen is screen 1.33. Now the slits are illuminated by a parallel beam of light. The slits are illuminated by a parallel beam of light. Parallel beam of light whose wavelength in air is 6,300 angstroms. The fringe width is we have a question like this. First you understand question now. What is given? A double slit apparatus is immersed in a liquid of refractive index 1.33. So refractive index of a medium, what is that here? Liquid 1.33. Now total apparatus is immersed in a liquid. Of refractive index is 1.33. It has slit separation of 1 millimeter. Slit separation, distance between two slits, how we represent? D, small d. Small d is equal to what? 1 millimeter, 10 to the power of minus 3 meters. And distance between the planes of the slits and screen is 1.33. Distance between the planes of the slits, here it is 1.33 meters. Distance between the planes of the slits and screen is 1.33 meter. Like that. And the slits are illuminated by a parallel beam of light whose wavelength in air is 6,300 angstroms. Fringe width is in air, wavelength of light in air how much? 6,300 angstroms. Angstrom, 1 angstrom is equal to how many meters? 10 power minus 10 meters. You know that. Lambda in air is equal to 6,300 into 10 to the power of minus 10 meters. Now we want to calculate fringe width is. Fringe width where? In a medium. Beta liquid. What is formula for fringe width? In general, what is formula for fringe width? Beta is equal to what? Lambda d by d. But in a medium what way formula? Lambda d by d into mu. Lambda medium becomes what? Lambda by mu. Now in a beta in air medium how much? Lambda d by d. But in a medium, total apparatus is immersed in a liquid. So lambda in liquid how much? It becomes what? Lambda by mu. That's why lambda d by d into mu. Is it clear? Now we substitute now. Beta medium is equal to lambda value how much? 63 into 10 to the power of minus 8. 63 into what we write now? This is 10 to the power of minus 8. Now capital D how much? 1.33 by small d how much? 10 to the power of minus 3. Here mu how much? 1.33. So 1.33 gets cancelled. What we are getting now? Here 10 to the power of minus 3, 10 to the power of minus 5. Now we got beta in medium is equal to 63 into 10 to the power of minus 5. So what we write now? 0.63 into 10 to the power of minus 3 meters. Now 0.63 instead of 10 to the power of minus 3 what we write? Millimeters. Now beta in medium how much? What is the answer now? 0.63 millimeters. Is it clear? Here d by d, capital D small d value, there is no change in capital D small d, but lambda value changes. Lambda in medium how much? Lambda by mu, like that. So that's why what is the answer now? 0.63 millimeters. That only correct option.